All right. Well, good morning, good afternoon, everyone. Welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. We are coming up on the end of March, but we still have a lot of events between now and the 31st. So do spend a little time on our site, exploringbytheseat.com. You can find everything we have coming up. And then just recently, we released our April events, the first, say, 2 weeks or so of April. There is a lot of events coming your way. So we hope to see your classrooms coming in and joining us for those. So today's event, we are going to explore the skies of Venus. So we're going to spend a little time with Paul Byrne. He is a planetary scientist who worked on NASA's Messenger mission, which was the first mission to orbit the planet Mercury. So he's really interested in comparing, contrasting surfaces, interiors of planetary bodies like Earth to understand why planets look the way they do. He's working with a pretty cool team of scientists and engineers to design a mission for Venus called Phantom. It's going to feature a balloon and carry instruments through the clouds of Venus. That sounds pretty darn cool. So we're going to grab Paul from backstage right now. Here we go. Hey, Paul, how are you?
I'm well, Joe. How are you doing?
Yeah, good, Paul. Great to have you joining us today.
Delighted to be here.
And I should mention Explorers Club as well. Member of the Explorers Club. You keep pretty busy.
I'm pretty busy. I actually got back from Washington, D.C. on Monday, where I was meeting with lawmakers to talk about why NASA is such a good investment for the country and why they should keep paying for it. So I do a lot of little things, and I'm definitely interested in helping people pursue and explore Earth and space.
All right, very cool. We've got a great crew hanging out with us today. We're going to take questions when the time comes. Or for now, Paul, we'll let you take over for a bit and take us into your world.
Excellent. Okay, I am going to share my screen. And this should pop up momentarily.
All right, I see it. Looks good. We're ready.
Awesome. Okay, cool. So basically what I'm going to do is just spend maybe 15 or 18 minutes just explaining why we explore Venus, or why we want to explore Venus. And Joe mentioned at the beginning that a lot of what I do is tied to understanding why planets look the way they do. And one of the biggest things that drives a lot of people like me is, why does Earth look the way it does? And how is it that Earth worked out pretty well for us in terms of being what we call a habitable world, where so many other places in the solar system seem to be really inhospitable? And I think the key to answering this question is Venus. So let me explain why as I go through these slides. So first off, I'm going to assume that maybe not a lot of people know that much about Venus. So let me kind of introduce the world to you. So it's about 80% the mass, or if you like, the amount of stuff that's there compared with Earth. So it's a little smaller than Earth in terms of how much stuff there is and how much rock and metal make up Venus, but it's almost the same size. That means that its density is a little lower. But if you were to look at our solar system from a few tens of light years away from, say, another planet, let's say you're an alien astronomer and you have your squiddy tentacles and you have built a telescope and you can look to our solar system, you would see that on paper, Earth and Venus are very, very similar. They're almost the same size. They orbit the same star. They're probably about the same age. They're probably made of the same stuff. And you might think, therefore, that the two places are quite similar. But in fact, we've known for quite a while that Venus is completely unlike Earth, at least today. And that's a really important question for us to try and answer. How is it that you would end up with two worlds that are very similar in size and have a lot of things, again, on paper that suggest they should be similar, and in fact, they're very different? I'm pointing a little picture here in the lower left. This is an image. Almost all the images you're going to see in this presentation are computer generated or artist impressions. We actually don't have very many good images of Venus for reasons I'll talk about a little bit more. The actual picture of Venus you're seeing here is Venus taken with two different kinds of camera. One that can see in the infrared, which is what you see on the left side of the planet. Or sorry, correction. That's the ultraviolet. That's what it looks like. If you had the ability to see in the ultraviolet, like bees can see into the ultraviolet, this is what Venus would look like. To us, it's more like kind of a creamy ball. But you'd see all these kind of weird structures in the clouds if you looked in the ultraviolet. And if you had infrared, which is some, say, snakes can see in the infrared, for example, what you'd see is actually what's there on the right, which is the lower atmosphere of Venus is really hot. And that lower atmosphere glows, and it basically glows up through and shines through the upper clouds, which are cooler. We discovered this for the first time in the early 1960s, and it really put pay to the idea. Prior to that point, a lot of people thought that because Venus was about the same size as Earth and should, on paper, be similar, that it might be covered in jungles and lush tropical rainforests. And in 1962, NASA's Mariner 2 mission flew past the planet just one time, but was enough to tell us that, in fact, There are very, very high temperatures lower down the planet. And in fact, we now know a lot more about Venus because in the years since, we've sent quite a few missions there. So the sky of Venus, this is again artist's impression of what the sky looks like. We have no photos from the sky, but we do know that there's a global layer of clouds around Venus, and these clouds are very bright. They reflect most of the sunlight that reaches them. That actually makes Venus one of the brightest objects in the night sky. You have the sun, the moon, Venus, and then the International Space Station in terms of the top 4 brightest things. It's this global layer of clouds that we can have to thank for making Venus so bright. These clouds are not water vapor clouds like clouds on Earth. They are in fact clouds of sulfuric acid, which is not great. However, even though the atmosphere itself is almost pure CO2, carbon dioxide, we actually flew 2 balloons through this atmosphere in 1985. The Soviet Union had 2 missions called Vega 1 and Vega 2. These balloons were very, very small. They were about 10 or 11 feet across. They had a very small science payload, and they only operated for 2 days. But they were enough to show scientists and engineers that you could actually float a balloon for much longer in the Venus sky. That's something that I've been spending quite a bit of my time talking about, that Joe alluded to. But what we found, what was fascinating with these balloons, is that the actual atmosphere of Venus at about 40 miles above the surface is actually about the same temperature and pressure as the room you're sitting in right now. It's the only other place in the solar system where we have room temperature conditions, which is fascinating. So if you were there, you would need to be protected against the sulfuric acid droplets. You could wear a special suit for that, and you need to have a mask to breathe air or oxygen because you couldn't breathe the CO2, but you wouldn't need to be protected from the temperature or the pressure. It is basically what you find in a room on Earth, which is, I think, amazing. So the sky is kind of terrible, but also kind of okay, but the ground is absolutely terrible. And that's why the Venus itself is a very difficult place to explore on the surface. And the reason for that is because the temperature at the surface is about that of a self-cleaning oven. It's almost 800 degrees Fahrenheit. And the pressure is equivalent to being about half a mile underwater on Earth. They are very difficult conditions for us to design a spacecraft to be able to withstand. And certainly we are a long way off having the kind of rovers that are driving around Mars operating on Venus. We would need to build these things to be much, much more resilient to those high temperatures and high pressures. And the simple fact that the reason it's this high temperature and high pressure is because there's so much atmosphere, there's so much of this CO2 air that it's just crushing pressures and temperatures at the surface. However, there have been a few missions that made it there. The Soviet Union in the 1980s landed a few large metal titanium robots. They operated only for a short period of time because the temperature is so high that it's very difficult for them to last more than an hour or so. But in that time, they took a few images. They took a lot of measurements. They told us that the rocks are made of a material called basalt, which is one of the most common kinds of rock we find everywhere else in the system. The Earth's ocean floors are made of it. Much of the moon is made of it. Much of Mercury and Mars is made of basalt. So it's not surprising that much of Venus is made of this stuff as well. Venera 13 and 14 both landed in 1982. They took photos of the surface in color, which is this image, again, is a computer-generated image, but it's sort of informed by actual images we took from the surface. And Venera 13 and 14 both recorded the first recordings of sound from the surface of another planet. We later on did that for Mars. We've had a few missions that have done that for Mars, but for the first time we ever heard alien wind, it was actually happening on the surface of Venus, which I think is pretty cool. There's something very surprising about the surface of Venus. And if you've ever looked at the night sky and you've looked at the moon, you know that there are lots of these things we call craters. And there are big craters and small craters, and they're all over the place. NASA had a mission. In fact, it was the last mission that NASA has sent to Venus in 1990 called Magellan, so 35 years ago. And Magellan had the ability to peer through those thick sulfuric acid clouds that cover the whole surface to see the surface. If we were orbiting Venus ourselves, like I said a few minutes ago, we would see a very bright, cream-colored, featureless ball. We certainly cannot see the surface from space with our eyes, with what we call visible wavelength light, the way we can for, say, Earth or the moon or Mars. We have to use radar to peer through that thick cloud layer to get onto the surface. And that's what NASA's Magellan mission did. It carried a very powerful radar. And over about 4 years, it imaged almost the entire surface. The data are okay. They're not great. They're not as good as the modern stuff we have for other places like the moon or Mars. They're okay. We're going to go back to Venus to do much better mapping, and I'll talk about that in a few minutes. But a really surprising thing that came out of the Magellan mission was that there are not many craters on Venus. And the reason that's surprising is because we would expect if there were parts of Venus that were really old, they would have lots of craters. And we would expect that there are some places that are brand new, they would have no craters. And there are definitely places on Venus where there are no craters, but there are no gigantic basins. We call things that are bigger than about 60 miles across a basin, an impact basin, to distinguish it from an impact crater, but really you could say they're all craters. But there are no giant impact basins on the surface of Venus. They seem to be distributed at random. There doesn't really seem to be a lot of sense as to where they are or why they're where they are. So we don't really understand that. There's no crater is smaller than about 2 miles in diameter. And we think the reason for that is because the atmosphere is so thick. Something that would make a crater only 2 miles in diameter actually gets burned up before it reaches the ground. It can't make a crater at all. But we don't find gigantic basins, and we don't find areas that are really cratered and areas that have no craters. We actually don't really know quite how to interpret the surface of Venus at all through the lens of its cratering record. But what we can say is that if there were truly ancient parts of Venus, they would have lots of craters, and we don't see that. So the surface of Venus, the planet itself, is probably as old as the solar system, but the surface of Venus looks to be much, much younger geologically. Now, I am a geologist by training. And when I talk about things being young or old, I don't mean that in the way a normal person does, because to a geologist, 10 million years ago is young, and to a normal person, that nothing that old is young. But in the context of solar system science, there are parts of Venus that look to be as young as any parts of Earth. And Earth has a lot of young surfaces because Earth has a lot of processes going on to make that surface young. And so we really don't understand the impact cratering history or record of Venus. That's something a big unknown. There's actually a whole pile of other unknowns. We don't know if there's volcanic activity or even geological activity generally at Venus. There's good indirect, what we call circumstantial evidence that there's a lot of volcanic activity. There was a mission called Venus Express that the European Space Agency operated at Venus for about 10 years. And about 20 years ago, Venus Express, while it was still there and working, detected these areas in the surface that it had a particular instrument that could see through those clouds. And it saw areas get really hot really quickly and then get cool again. Now, I mentioned that the surface is really hot. Lava is a lot hotter than even the hot surface of Venus. So if there had been a lava flow, it would come out, it would get really hot, it would be very distinctive compared to the surroundings, but it would cool down to sort of the what we call the ambient or sort of the general surrounding temperature pretty quickly. Maybe that's what Venus Express found, but it wasn't designed to look for them, so we can't be certain. We also know that over several decades that the composition of the atmosphere has subtly changed. And that is consistent with potentially the injection by volcanoes of particular gases like we have on Earth into the atmosphere. We know this happens pretty regularly on Earth. But again, because these missions were not explicitly designed to search for this, it's very hard for us to be certain about what we measured. We have some basic questions like, what is the ground made of? This is, again, an artist's impression of what the surface would look like. But we do know that from those handful of images that we got back in the 1970s and 80s from the Soviet landers, that some parts of the surface look completely different to other parts. And they look like they're made of blocks. And like I said earlier, we think much of it is made of this basaltic material. But the short answer is we don't really know. We have very, very limited information on what the ground is made of. And if without that information, it's very hard for us to explain how the ground gets made that way. And that has implications then for all kinds of things about how we would unravel the history of Venus. The atmosphere of Venus, which is a place that I would love to fly our balloon concept through that Joe mentioned a few minutes ago. The atmosphere is a fascinating place, but one of the most distinctive things about the Venus's atmosphere is that it rotates way, way faster than the solid ground does. In fact, it rotates about 60 times faster than the solid body. Now think of it on Earth. Our planet rotates faster than our atmosphere. Our body, the solid body of Earth, takes what we call a day, 24 hours, to go around its own axis. The atmosphere of Earth takes between 5 and 6 days to go around. And as a result, we do not have crazy, catastrophic hurricane-like winds at the surface most of the time, thankfully. In the case of Venus, the upper atmosphere moves extremely fast, and we have no idea why that is. So that's a thing that we would like to figure out. There's also one more foundational thing that we do not know about Venus that we sure would like to understand. And that is, what was Venus like a long time ago? So remember at the beginning I said that on paper, if you were to write down the vital statistics of both worlds, Venus and Earth are about the same size. They're made of presumably the same stuff at about the same ratios. They go around the same star, not very different distances. We do know from some measurements taken in the 60s and 70s that it looks like the atmosphere of Venus has lost a lot of water. Now, I'm going to skip over some of the chemical details for why that is, but the conclusion we have is that it looks like at some point Venus had a lot more water than it does today. It has almost no water today in the atmosphere. And the shorter answer for why is unclear. There's two leading possibilities. One is that Venus was always terrible. It was always really hot at the surface. It was too close to the sun to cool down. It started off being a completely volcanic world. There was a lot of water in the atmosphere, but it was steam. That's the condition we think Earth had very, very early on in Earth's history, that there was a very steam-rich atmosphere. But what we think happened on Earth was that the planet was able to cool itself down enough that that steam condensed out and basically fell as rain to fill in and form lakes and then seas and eventually our oceans. That's how we think we got our oceans. Now, in the case of Venus, one possibility is that that never happened. That steam-rich atmosphere was left there, the planet was too close to the star, it was too hot, and it was just terrible the whole time. But there is a tantalizing possibility that for a long time, Venus might actually have done what Earth did. It may have cooled down. It may have rained out that steam into liquid water. And for a very long time, Venus maybe looked a bit like this picture. Again, an artist's impression. We do not know this to be true, but we have a hypothesis, a scientific idea or theory that we're going to try and test to work out if Earth and Venus both had oceans at the same time. And if they did, that would be an absolutely huge discovery. And the reason for that is because that has implications not just for the possibility of life emerging on Venus, but also it tells us a great deal about our own world, how our own planet came to be a habitable place, and even what might happen to Earth in the distant future. So this is one of the biggest reasons why we study Venus, to answer this question, because either yes or no has huge implications for how we understand our own world and how it became habitable. Now, the good news is, I remember I mentioned a few minutes ago that the last time NASA sent a mission to Venus was in 1990. Thankfully, we are going back to Venus. We have to wait another few years before it finally happens, but we are going back to Venus. In 2021, 4 years ago, NASA picked two missions, one called Veritas and another called Da Vinci, to go back to Venus. Veritas, this is again an artist's impression of what this looks like. Veritas is a big orbiter, and it carries a very, very powerful radar to peer through the clouds, which is kind of the impression of what you're seeing here in this picture. But instead of taking the relatively low resolution images that the Magellan mission did, it will take much, much higher resolution images. And I'm very, very excited about the sort of stuff we're seeing. It'll also be able to take remote measurements of what the surface is made of. It won't definitively answer the question of what the ground is made of, but it will be much, much more instructive than what we currently have. The other mission that NASA picked is called Da Vinci, and I really think this is a cool mission. Da Vinci is basically an armored ball about 4 feet across, made of titanium, and eventually will be dropped through the Venus atmosphere. And on the way down, it's going to have these little ports that will suck a little bit of air in, and it'll have onboard computers to measure what that air is made of and actually tell us really important things about what that atmosphere is. Not just about what it's made of today, but Da Vinci will have the ability to measure things in the atmosphere like what we call noble gases that will actually give us information on what the atmosphere was once like in the geological past. Remember I talked about how important it is to understand if Venus potentially ever was habitable? Da Vinci is going to take a huge leap forward in our understanding of basically trying to answer that question. What I'm particularly excited about as someone who studies geology is that we have never taken photos of the surface from above. We have radar images, but they're not photos. They don't work the same way. All the other literally 8 photos we have, 8, like you can count them on both hands, 8 photos for the surface of Venus came from landers. We've never had aerial photography before. And as the Da Vinci probe is falling to the surface, it will take images for the last few minutes for about 2.5 miles up all the way to the ground. And those images will be the first ever collection of aerial photos we'll have. They're going to be really, really important for us to figure out what the surface is as well. And then we're going to have a third mission about 2 weeks after NASA announced in 2021 the selection of the Veritas and Da Vinci missions. The European Space Agency announced that it's going to fly a mission called Envision, which is also a radar mission to Venus. Now, you may wonder, why are we sending so many radar missions to Venus? Well, we send lots of missions to Mars, and they all have cameras. But the cameras do different things. And some of them are sensitive to one kind of wavelength, and some of them are designed for one kind of science investigation. And together, they tell us a great deal about Mars. Because we cannot easily fly cameras to Venus, or rather, because cameras can't really see the surface of Venus, we want to fly radar. So the more radars we have, the better. They're basically the equivalent of flying cameras at Mars. Envision is going to do a slightly different set of things to what the Veritas radar mission is going to do, but it's going to give us very high resolution images in some places from radar. It will also help measure composition. And for the first time ever, it's going to be able to see with radar through the surface to the underground, to the subsurface, to tell us what might be happening in terms of perhaps as much as half a mile under the ground. That's huge. We've never done that before for Venus. We have done it for the moon and we have done it for Mars. And every time we've done that, and we widely use this technology on Earth, we learn a great deal about what's there. And so for the first time ever, Envision will do that as well. So what really excites me is that the future of Venus exploration is bright. There's potential for us to do so many more things. Like this is, again, a picture I put together a few years ago. Again, totally scientifically accurate, but an artist's impression of what's there. We do not have photos of this kind of quality yet for Venus. But you can see in the top right, there's an orbiter, and there's still orbital science for us to do. On the top left, that's an example of the kind of thing we could fly as a balloon through the surface, through the skies, that would be able to measure both what's happening in the atmosphere, but also the surface, and even underground. And then right in the middle, that kind of weird coppery looking thing is, there are ideas, at least, no one's done this yet, but there are ideas for putting small little landers that are designed to work under those incredibly high temperatures and pressures that would last for months or even years onto the surface of Venus, being able to detect things like lava flow eruptions or volcanic events or earthquakes, or even telling us what the weather is like on Venus. And so I cannot wait for that to happen. But like I say, this is one of the most interesting places in the solar system. It's easy for us to get to, and I cannot wait to see what these missions tell us in the future. So I'll finish there. I'm going to stop screen sharing, and I'll throw it back to Joe.
All right. Awesome, Paul. That was a great presentation. Exciting to see that a little more attention is being paid to Venus. You really, I mean, you see it almost every night in the sky. It's bright. It stands out. But you're right. It's been a long time since NASA's paid a lot of attention to that planet.
Exactly.
And a lot to learn, because, you know, if similar things are going to happen to Earth in the future, it would be nice to have a heads up and kind of learn about some of the things that led to those conditions. That's
exactly it. Yeah. And then, you know, there's a growing interest and a growing capability with things like the James Webb Space Telescope to explore Earth-sized worlds orbiting other stars. And we're super excited about that. But we will potentially never, certainly it's going to be a very, very long time before we can ever send a spacecraft to a planet orbiting another star. But we have an Earth-sized world right next door. And so Venus offers these opportunities that really we have nowhere else. That's what's so cool about it.
All right. Well, the classroom's tuning in right now. If you want to start putting some questions into the chat, we'll work some of those questions in for Paul. But as we wait for some questions, I pulled together a little Kahoot quiz behind the scenes. So give me just a quick second here to share my screen. It should be coming up now. If you would like to join us today and play some Kahoot, you need to go to kahoot.it. It'll ask you for a PIN number. It's 678-3892. So if you're lucky enough to have a tablet or a Chromebook at your seat, you could join that way. If not, your teacher could pop this up at the front of the room. You could shout out your answers to him or her. I know we have some home students today, so you could scan the QR code and that would bring you in to the Kahoot. If you absolutely can't join with tech today, don't worry about it at all. You can still play along and see how you do with those questions. So we wait to see if some students come and join us. I've got a question here in the chat to get us started. Paul, this is from Mr. Green's crew. And they're wondering, there's lots of things to choose from in our solar system, you know, even outside in the galaxy, the universe. So what led you to really focus on Venus? What's got you zeroed in on that planet?
That's a great question. And so I should tell you, I started doing Mars. And then after Mars, I did Mercury, and I was really interested in those places. And we had spacecraft going to those, and I'm still interested in those. But what I found interesting about Venus was that despite the fact that we had all these basic questions about what the planet's made of, what the skies are like, what the ground is like, we had not been sending any missions there. And so something that really got me interested was, why are we not going back to Venus? And then once I learned more and more about it, I got more and more excited about exploring it and understanding it. So I will say that I actually study a whole pile of places, but I think Venus has a special place in my heart because for a long time, it kind of got ignored a little bit. And so I wanted to do my part to try and bring some attention back to it.
All right, very cool. Well, I can see we've got some groups joining us, which is great. We'll give them another few seconds to get in right now. So you kind of mentioned before we got started that you Part of your job is speaking to government officials and talking about why exploring beyond our planet is important. And I wonder, when you're in meetings like that, what kind of questions do you get? Are they, very interested? Have they done some research in advance? What's it like when you're talking to people like that?
Yeah, it's really interesting, and it depends. The answer depends a lot on who we're talking with, because, say, for example, some representatives or senators have districts where there might be already a big aerospace or space focus, and others might be from places where perhaps there isn't much of a focus. So the kinds of questions you get will differ. In places where there's already a fairly well-established aerospace or space science technology focus, they'll have usually more specific questions because they're familiar with what their, say, for example, a NASA center or a big aerospace company will do. In instances where we go to talk with folks who perhaps don't have a NASA center in their state for their district, for example, often the questions are kind of more high level. Why are we doing this? What's the benefit to the United States for doing it? And then we can say, well, we have all these cool spin-off technologies. We know that for every dollar that NASA gets invested, it returns $3 to the US economy. So it's a money-making machine. But more broadly than that, I'd like to tell people that, everywhere around the world I've traveled, which is a lot now, I see kids wearing NASA t-shirts. I mean, I can think of no other country that has another entity that they export the way that the US has NASA. It's amazing the reach of that. And just empowering people to ask questions as to why are we here and what's around us is one of the most powerful things we can do. So we definitely help them understand that that's the power of NASA as well.
All right. And I think it's really cool too. A lot of students might not know, but a lot of technology that we're using down here on our planet came from those missions, came from experiments on the space station. It may seem like it doesn't apply to us back here, but there's so much technology that's really important to us here that's developed through these programs.
That's so right. Yep.
All right. Well, I think we've got a good group in here, so let's play some Kahoot. There will be 4 questions. True or false, multiple choice. The quicker you put in the right answer, the more points you're going to get. And let's see how we do today. So here we go. First question coming your way. One of the missions Paul worked on was the first to orbit. Was it Mercury, Mars, Saturn, or Jupiter? You have 4 options there. One of the first missions Paul worked on was first to orbit Mercury, Mars, Saturn, or Jupiter. What do you think? Got a few more seconds to lock something in. A little clue decoding for you. All right. Whew, most went with Mars. We do a lot of Mars exploration, and we've been doing that for a while. But no, I mentioned it in the beginning, Mercury, in the introduction. Very cool. All right. And then correct me, I might have my timing wrong. Is it 88 days is a year on Mercury to orbit?
Yes, yeah, but it's really complicated because it does this thing called, it has what we call a 3-2 spin orbit resonance. What that means is for every 3 days, it does 2 years.
Okay.
And so good luck trying to figure out how many birthdays you have on Mercury.
All right, very cool. Okay, let's see how we're doing here. Fuzzy Piranha in that top spot. Our next question is true or false? Venus is half the size of Earth. What do you think? Venus is half the size of Earth. True or false? You've got about 15 seconds left to lock in that answer. True or false? Is Venus half the size of Earth? All right, no fooling anyone on that one. We know Venus is often referred to as Earth's twin, or even I've heard it Earth's evil twin.
Earth's evil twin, yeah, exactly. Yeah.
I think we learned a little bit about some of those reasons today. But good job, crew. That's absolutely right. That is false. Venus is not half the size of Earth. A reminder, too, as we're doing the quiz, if you have some questions, grab them into the chat. I see a few coming in, but let's keep those questions coming. Let's go to our scoreboard. Fuzzy Piranha holding on. True or false? Venus is one of the 4 brightest objects in the sky. True or false? Venus is one of the 4 brightest objects in the sky. Got about 12 seconds to lock something in. Venus is one of the 4 brightest objects in the sky. True or false? Couple seconds left. All right. Good job, crew. That's absolutely true. Oftentimes, it's the first thing you'll see in the night sky is Venus pretty bright there out on the horizon. Yeah, our neighbor, not too far away.
And if
Okay.
someone asks you why Venus is bright, you can tell them it's because it has a layer of sulfuric acid clouds. That's why.
Very, very cool.
So
Well, that's going to relate to our next question, our final question. So Polite Dolphin has snatched the lead, and here comes our final question. It is a multi-select, so you need to select 1, 2, or 3 answers here. If you were high in the, oops, that's bad spelling, typing too quick. If you were high in the atmosphere of Venus, which 2 would you need protection from? The temperature, the CO2 gases, the sulfuric acid rain, or the pressure? So if you were higher up in the clouds around Venus, which would you need protection from? All right, a bit of a tricky one with the multi-select, but if I look at the answers, a lot of students went with the sulfuric acid rain and the CO2 gases. Good job, very cool. Okay, let's take a look at our podium, and then we'll switch back to Q&A mode, and we'll go maybe the next 15 minutes or so with some more questions. So Majestic Camel in third, Fuzzy Piranha in second, and holding down that top spot, the Polite Dolphin holding on for the last 2 questions. All right, very cool. Well, thanks so much for playing along with us. And let's stop this screen share, and let's kill the music, and let's get into more of that Q&A action. So we've got a class here in Brampton, Ontario, so Canada, not too far from me, maybe an hour or so from me. You mentioned that there's some equipment or technology that's going to Venus on the missions. Is this older technology, or is it really, really new tech that'll be going on these new missions?
So this is the really exciting thing. It's new tech. And what we've seen in the last 20 years or so is that we've had all these new missions to, say, Mars or the moon, or even parts of the outer solar system. And every time we send a new version of something, we get so much more data and so much more science. So it's not that we're sending devices that didn't exist back then. We're still sending radars, we're still sending other things, but the modern technology we have, the ability to miniaturize things, think of what a smartphone now does compared to a smartphone 5 or 10 years ago. And every time we've sent new stuff to a place, we've learned new things. So strap in for the new science we're going to get for Venus with these new missions.
All right, very cool. Well, I have another question here about one of those new missions, the big titanium ball. Will that survive its landing, or is it kind of grab info as it falls and then poof?
All right, so this is one of the reasons I think this mission is so cool. It is not required to survive. It is not being designed to survive. It is not being designed. There are no legs or landing pads. However, when you talk to the scientists and the engineers, they think it will survive for perhaps 20 minutes. So, and one more thing, and I didn't really have time to get into this. This is the wild thing. If you try and land on Mars, okay, if you try and land on the moon or Mercury, no one's ever tried to land on Mercury, but if you land on the moon, there's no air at all. So you can just use rockets to come in. It's tricky, but it's doable. If you want to land on Mars, there's enough of an atmosphere that you can slow down a little bit, but there's not enough of an atmosphere you can slow down a lot. And so landing on Mars is really tricky and requires parachutes and retro rockets and all kinds of stuff. The way we land on Venus is we come in with the parachute, and then at around 40 miles up, where that room temperature and pressure air is, we just cut the chute off and we free fall. And that's because near the surface, the air is so thick, it's actually more like the bottom of the ocean. And so basically things just fall. So the Da Vinci probe will actually fall for till around an altitude of 45 miles, and then they'll cut its parachute and just free fall. It's like about an hour to traverse all the way to the ground. And when it hits the ground, it'll hit the ground at about 30 miles an hour. And because this is an armored ball of titanium with stuff inside, even though it's got delicate stuff inside, we think it'll survive, and long enough for the temperature to kill it. So it's not supposed to, it's not designed to, but we're hoping that it will, which would be cool.
Yeah, it's very cool. And you think, when things hit the Earth, like a meteor or something, meteorite, it impacts pretty hard. But 30 miles per hour, that's not that intensive an impact.
It's not that intensive. I mean, I don't think I personally would like to be in something hitting at the 30 miles an hour. But if we can build the devices inside this thing to be resilient to that impact force, and and we certainly, even when the Soviets landed stuff on the surface of Venus, they came in at around the same speed, and they knew that, so they designed it to do that. In fact, in at least one case, one of those landers came and tipped over as soon as it landed. So it got all the way to Venus and then tipped over, which is a bit annoying. So they tried again. But we know we can do this. And like I say, I'm not sure I'd like to, but we can build the instruments to be okay with 30 miles an hour.
All right. So joining us, Caesar, all the way from Nicaragua, is curious if you were on the surface of Venus, maybe you had a really protective suit, what would happen to you if you took your helmet off?
Yeah, okay, you would die. You would die quickly, but I don't know what would kill you first. So the pressure would squash you. There's a reason we do not send divers down a half mile without special protective, basically submarines. We can go deeper. We've gone much deeper on Earth, but we use very specialized submarines. So if you took your helmet off, you would immediately be squashed. That wouldn't be great. You would also be boiled. You wouldn't go on fire because there's no oxygen in the air for there to be a fire, but you would basically get baked instantaneously. And also, because there's also a lot of chemistry going on, it would also do weird things to you. And just generally, the good news is I don't think you'd be aware of it because it would be so quick. But the bad news is they're also not getting your body back. But I often ask my students to think about what would kill you. And there's probably 3 or 4 different things that would kill you at the exact same time. It is not a place for the faint of heart.
All right. So the helmet stays on if you have a suit that can protect you from
yes,
all
please. Yes.
Of those crazy things. Okay. Another question here from Mr. Green's crew. He's got some students who are very interested in space, and they wonder what kind of ways do people get to work with NASA or other space studies, and is everyone an engineer?
Okay, absolutely no. So the single biggest way that people get to work in space-related stuff is because they're passionate about it. What's really cool, and it's not just NASA, it's the European Space Agency, it's the Canadian Space Agency, there are space agencies around the world. They have a lot of engineers, they have a lot of scientists, but they have people who work on managing stuff. So they have folks with management or financial backgrounds. They have people who work on communication, science communication, but also liaising with government. So people from poli-sci backgrounds to communication backgrounds. They have people who write about the discoveries. So they have people who are journalists as a background. So the amount of different types of careers there are, even within NASA, is staggering. It's absolutely not all, by any means, engineers or scientists. What I do tell people is that to the extent that you're interested in this kind of stuff, try and take as many science and math courses as you can, because they're the kinds of trainings that are useful that you can then apply in lots of different ways. So to the extent that you can take math, physics, chemistry, biology, I should say that we have a whole realm in what we call planetary science with people who study biology. We actually call it astrobiology. It's trying to understand the origin of life on Earth and potentially other planets. So you could be someone interested in microbial life. You could be interested in how plants develop. You could have an interest in fossils. You could have an interest in almost anything I can think of. There are people who work for NASA who are lawyers. I cannot articulate enough the variety and diversity of backgrounds that NASA and other space agencies need. But if you're interested, follow what your passion is and try and take as many math and science courses as you can. That's the advice we generally give folks.
Yeah, and I think you really you shared one really cool aspect with us as well for those artists out there. We don't have all those pictures, but by taking the science that comes back from the missions, then we can create these really cool renderings of what we think things might look like using good data.
Absolutely. And they're so important for when we propose a mission. If we're, say, at the point where we have an idea, but we don't have the money for it yet, we often will go through these different procedures where we propose them. And what's so central to that is an arresting image or something that's evocative that kind of helps people understand on a human level why we want to do this. So even the artistry is such an important part of what we do.
All right. I've got 2 cool questions from some grade 8s in Illinois. So we'll do them one at a time. The first one touches on what you were just talking about, astrobiology. Would it surprise you if extremophiles might be living somewhere on Venus?
So, going back to the 1960s, there have been suggestions that there could be stuff living in the upper atmosphere of Venus because the temperature pressure conditions are so similar to Earth. Would it surprise me? On the one hand, it would be extremely surprising because if we found evidence of alien life anywhere, I would be like, wow, this changes everything. On the other hand, it's probably one of the least surprising places where there could be life, because as difficult as conditions are there, and there are issues with how much sunlight there is, how much water there is, it is one of the more Earth-like places in the solar system. So I think I would be overjoyed if that would probably the dominant feeling I'd have if we discovered extremophiles there.
All right. And so their second question is, if you could plan your dream mission to Venus, what would it look like?
My dream mission is a mission that you alluded to at the very beginning. For the last few years, I've been working with a lot of colleagues around the world and with NASA's Jet Propulsion Lab to develop a balloon concept that we want to fly. So remember, I mentioned at the beginning that the temperature pressure conditions at about 40 miles up are perfect for us to fly a balloon. And with modern technology, whereas the Soviet balloons lasted for about 2 days, we could design a balloon that might last a year, and it would have modern, state-of-the-art onboard analytical equipment to go and things that tell us things like, are there microbes in the upper atmosphere of Venus? Or, there's so many things we could do with that. That's my ideal mission. And the really cool thing about it is that we would also put cameras on it. And so for the first time ever, we would be able to take photos of the sun setting or rising over the clouds of an alien world. And so that is the mission I dream about, and that I spend more than a little bit of my time working to try and make happen.
Yeah, that'd be pretty cool. Okay, I've got 2 more questions for you, Paul, before we wrap up for today. The first one, again, about the mission with the probe dropping through the atmosphere. How quickly can it send data back to Earth?
This is a really, really important thing, and this is a really good question. It turns out that the problem really isn't getting the data. The problem is actually sending it back. And so in the case of the Da Vinci probe, and this is how the Russians did it in the 1970s and 80s too, Da Vinci will be dropped off by a small little vehicle. Now, it's not an orbiter, but it does have a powerful radio on board. And so as the probe is going through the atmosphere, the engineers behind the Da Vinci mission figured it was too difficult to send those data back to Earth. There are ways you could do that, but it's too difficult when it's falling like this. So instead, as it's falling, there is this object overhead. But the thing overhead is moving very, very quickly. So there is a very narrow window of time for the probe to get all those data up back to that thing. And then once it has them, it can take its time sending them back to Earth. That's not difficult. So they've been very, very careful, the engineers and the mission designers, to make sure that things go exactly in a certain sequence. So we get all those data back from the probe up to the thing above and then back to Earth. But it's a great question, and it is something that we often have to be very mindful of when we design these kinds of missions.
Okay, last question from Mr. Green's crew. They're wondering, you've worked on missions before, including kind of collaborating on this new potential mission, exploring in the clouds. So are there times when there's, things you really wanted or were pushing for, but you kind of had to let things go to focus on other aspects? And what's that like?
Yeah, so if we ever made a reality TV show of how NASA missions come together, I think it would be a big hit, because there's a lot of drama behind it. So the mission that we've been working on, and you mentioned earlier, we call Phantom, is designed at a certain, basically, price point. NASA gives us guidance on how much these things can cost. And with more money, you can do more stuff and you can be more capable. But we're not able to, for a variety of reasons I'm going to skip, we're not able to propose that exact configuration for the next upcoming mission. NASA makes decisions frequently on what they'll allow and what they won't allow. So what we're doing now is we're pivoting, and we're taking this and we're basically taking some bits off it to make it cheaper, essentially, for the next competition that we think NASA is going to have in 2 or 3 years. And so I think I'm pretty confident that we're going to get this flying. I think it's a really compelling science mission, and I think we just have to be patient. I have to be patient. I have to tell my team we have to be patient. How does it feel? It's really, it can be emotionally difficult sometimes, because the thing is, like any project that takes a long time, you put a lot of time and energy and emotional, a lot of what yourself into it. And so when things hit a roadblock, or things don't happen, or the timeline gets changed and things get delayed, you just have to learn how to roll with it. And all of my mentors have told me that, and I'm sure I'll end up telling the people I'm mentoring, you just got to, many of the missions we have, including Veritas, Envision, and Da Vinci, the 3 new Venus missions, all of them were proposed multiple times before they were picked for flight. Yeah. So it's a marathon, not a sprint. And I often have to remind myself of that too.
All right, very cool. Well, I think that'd be a really awesome TV show to kind of go through that process with all the new projects. Maybe even people at home could vote and save a project with crowdfunding or something.
I think that'd be really cool.
That'd be pretty cool.
To see that. Yeah, exactly.
Yeah. Awesome. Well, I want to start off with a huge shout out to the students joining us today and those who will catch the recording later this week. Thank you so much for hanging out with us. There were a lot of grade 6 students today here in Canada, especially. That's a focus of science in grade 6. So great to see all those classrooms. Thanks for playing Kahoot with us. Always lots of fun. And Paul, what a pleasure to host you for the first time. Thank you so much for taking us.
My pleasure. Loved it.
Yeah, taking us to our neighbor, taking us to our twin. And we can't wait to watch and see how these, the confirmed ones and maybe the new mission come together.
That'll be cool. That'll be cool.
Awesome. All right, everyone. Hope to see you later this month and into April. But for now, we're going to sign off. Thanks so much, everyone. Thanks, Paul.
Thanks, folks. Bye-bye.